deportivos en los resultados de las pruebas. Y también hay literatura que encuentra un efecto positivo cuando las comunidades reciben este tipo de equipamientos, pero efectos negativos o nulos cuando estos no son bien recibidos y terminan siendo elefantes blancos para las comunidades. En este trabajo yo analizo el efecto de una política implementada en el área metropolitana del Valle de Aburrá llamada Unidades de Vida Articulada. Este proyecto fue construido con el aval de las comunidades, con el acuerdo de las comunidades, y yo miro sus efectos en los resultados de educación y crimen. Para esto, yo comparo los colegios y los barrios que están cerca de estos centros culturales con aquellos que están lejos. Y debido a que estos centros culturales fueron implementados en años distintos, uso un modelo de diferencias en diferencias dinámico. Aquí explico dos mecanismos por los cuales este proyecto tuvo implicaciones positivas en las comunidades beneficiarias. El primero es que los estudiantes pudieron sustituir tiempo libre con actividades ofrecidas por estos centros, y el segundo es que debido a la gran inversión en iluminación y seguridad privada, estos centros culturales tuvieron un efecto en la reducción del crimen. Estos son la primera mirada de mis resultados con respecto a educación. Yo encuentro que los colegios cerca a los centros culturales mejoraron sus resultados en las pruebas a ver, especialmente por los alumnos más jóvenes, es decir, aquellos que se encontraban en grado tercero y grado quinto. Por otro lado, no encuentro un efecto claro para los estudiantes mayores y tampoco encuentro un efecto composición. Esto significa que estos parques no están generando, por ejemplo, que un estudiante se cambie de colegio en orden de estar cerca a un centro cultural. Con respecto al crimen, encuentro que en los barrios cercanos a los centros hay una reducción en los crímenes de robo a motocicletas y carros. Y aquí explico las dos principales contribuciones de mi trabajo. La primera es que este trabajo evalúa una política pública con la participación de las comunidades, y la segunda es que encuentro evidencia positiva de que la promoción de cultura y deportes genera bienestar en términos de mejoras en educación y disminuciones en el crimen. Aquí hablo un poco acerca de la literatura que se relaciona con mi trabajo. Tengo dos líneas importantes. La primera es la provisión de parques públicos y el crimen, y la segunda es con respecto a educación. En la primera línea tenemos que la provisión de parques y el bienestar está relacionado con un efecto positivo, ya que estos parques mejoran el bienestar de la vida urbana y la salud. La segunda línea se acerca de los efectos de seguridad que genera la inversión en parques, iluminación. Y la tercera son todos esos trabajos que evalúan políticas de presencia estatal, y esto pues está directamente relacionado con la provisión de bienes públicos como parques. En la segunda línea tenemos los resultados de educación, y son estos papers que evalúan los resultados de los estudiantes cuando estos están involucrados en actividades complementarias al colegio, como actividades deportivas y actividades culturales. En esta línea encontramos efectos mixtos, ya que todos estos resultados dependen de otros factores, como el factor socioeconómico de los estudiantes. Voy a pasar a explicar el contexto de la política que evalúo. Unidades de Vida Articulada es un proyecto establecido en el área metropolitana de Medellín, en Colombia. Es un proyecto que tiene por objetivo la transformación de barrios para la reunión de las comunidades, la promoción del deporte, la recreación, la cultura y la participación ciudadana. Algunos de los servicios ofrecidos por estos parques son librerías, salas de cómputo, clases de deporte, música y computación. Este fue un proyecto liderado por empresas públicas de Medellín, y estos parques fueron construidos en los viejos tanques de agua de empresas públicas de Medellín que hace tiempo proveían el servicio de agua a la comunidad, pero ahora son lugares abandonados y que no prestan ningún servicio a la ciudad. En un principio estos tanques fueron construidos a las afueras de la ciudad, pero por la expansión ahora están sumergidos en el área urbana. En Medellín hay 144 tanques PM seleccionó 20 por este proyecto y el ítem más importante que se tuvo en cuenta para la selección de estos 20 tanques fue que las comunidades favorecidas no tuvieran espacios para la recreación y el deporte. En este sentido, las comunidades directamente beneficiadas son aquellas de bajos recursos que de otra forma no podían acceder a todos estos servicios culturales y deportivos que estos centros culturales proveen de forma gratuita. Por otro lado, este proyecto fue establecido solo en Medellín, pero debido al éxito del proyecto se implementaron otros 2 centros en Itagüí y Bello, que son municipios que limitan al norte y al sur con Medellín. Yo realizo este trabajo teniendo en cuenta los 10 municipios existentes en el área metropolitana de la ciudad de Medellín. Cada UA responde a los resultados de talleres de diseño liderados con la comunidad. Esto quiere decir que EPM se reunió con grupos de interés. Perdón, creo que tenemos una pregunta. Cambiar a inglés. Okay, I'm going to try. Each UA responds to the results of the design workshops held with the community. In this sense, EPM developed meetings with interest groups like neighborhood leaders to ask about the real necessities of the community. In this sense, each UA is different to the other ones. Every UA has a mandatory component with sports and cultural service, but this can be varied between UAs. The UAs were delivered between 2014 and 2017. Here we have our UA before this policy, and here we have UA. And you can see that this project has a big investment in lighting and security. In this section, I'm gonna tell you the data and the empirical strategy, and I'm going to explain what procedure I implement to define the treatment and the control group. So I define treatment and control group based on the equivalent distance for schools and neighborhoods to closest UA. One school is treated if the distance is less or equal than 1.5 kilometers. So if a school has that distance to the UA, then the unit is treated. As the same way, I select neighborhoods as triggered those that are intersect but the buffer in some proportion. I select 1.5 kilometers because this is like 10 minutes walking, but I present results with other buffers and the intensity variables. This is the distance and the summary sizes for the distance from a school by municipality. As I told you before, we have UAs in 3 municipalities, but with this procedure, we have a treatment observation in 6 municipalities. And so all my results are presented with this data for the 10 municipalities in metropolitan area in Medellin, but I also present results without these 4 municipalities without treatment units. As the same way, you can hear the summary sizes for distance for neighborhood by municipality, and again, you can see the same pattern. This is the graph that explains the procedure. On the left, you can see the point in purple is a UA, and the point in green are schools. So those points inside this buffer are treated, and those outside the buffer are controlled, depending on the specification. And on the right, you can see the procedure for neighborhoods. The point in purple is again the UA, and those neighborhoods inside the buffer as in the treatment group, and those outside the buffer are in the control group. But as you can see here, some neighborhoods are not completely treated. So I use a specification that fixes these partially treated neighborhoods. And here you can see all updating UAS in the metropolitan area of Medellin, all the schools in this graph, and all the cultural, all the neighborhoods in this graph. So you can see as well that some schools can be that US in some cases are so closest to the other ones, so one school can be treated more than once. So I use a specification taking advantage of these variations between the treatment. About the data in education, I use test scores in the National Exam Saber for 3, 5, 9, and 11 grade by year and school level from 2012 and 2017. I use other outcomes, approval, dropout, and transfer rates, and I use administrative data before the treatment in 2010 for school controls. Here I present the raw data for all tests for math and languages, and you can see here that the control, this line defines the year of the treatment, and we present 5 years before the treatment and 2 years after the treatment. You can see here that the control group has better performance in education in both outcomes, and this is bigger in the math scores. But also you can see that the graphs has are a very similar trajectory. So this is a first look of the assumption of parallel trends. Here I present the descriptive statistics control in the pretreatment in 2010. I did this exercise for variables, for enrollment variables in all levels of education, and for the amount of teachers and the amount of total staff in the schools, but I present here only those with I find significant difference. So I include these variables in my principal specification, and you can see here that schools in the treatment group are bigger than in the control group. For the enrollment in primary level, and also for the amount of teachers. About crime data, I use administrative records provided by the National Police in period 2012 to 2017 by year and neighborhood, and I use homicides, theft to people, cars, motorcycles, and residents. Here again, I present the raw data by crime. Here you can see homicides and theft, and in this case, you can see that the control group has a worse performance in terms of crimes. You can see that it's biggest in homicides, but this is real similar in theft to people. Here again, car threats and motorcycle threats. You can see the same things, but here you can see that the motorcycle threats is very similar for the two groups. And the last one is the resident threats. This is where we find the biggest difference between the two groups. Here I explain the econometrical model. The regression I estimate is this one, where my dependent variable is the educational outcome in school C, and this S at time T. My treatment variable is equals to 1 for schools that are closest to the center. This means that the distance between the school and the cultural centers is less than 1.5 kilometers, and I use as a time variable close to a T equals to 1 after the opening of the center. I use a vectorial controls interacted by time variables equals to 1 in GRT and 0 otherwise, and I include school tests and time fixed effects. And the error term is called clustered at the school level. I also did this specification for the dynamic version of the model, and it's basically the same, but I separate, I isolate the treatment for every year. This can show you the evolution of the treatment and also confirm the hypothesis of parallel trends. And about crime, I did a similar specification, but in this case, as I told you before, some neighborhoods are not completely treated, depending on the specification. So I use this equation to try to solve this. Crime BT is equals to the percentage of the neighborhood area that remains in the buffer divided by the total area of the treatment group times the total crime in the neighborhood B at time T. So if one neighborhood is inside the buffer in 90%, then I assign this 90% in the total crimes in the total crimes for this neighborhood. This is only true if the crimes distribute normally across the neighborhoods, and we know that this is not true because we have hotspots of crime, but this is the best that I can do with the data that we have. I also estimate the dynamic version of this model, and here I present the principal results for education. In this table, you can see the results for language and math, and you can see that we find that schools close to the cultural centers has an increase of the performance in the test scores in 0.1 deviation, standard deviation. And this effect remains across the different specifications. Here in the first column, we have the specification with no controls for all the schools. In the second and final column, we have the specification for those with no control for those schools that we have control, and in the last one we have those schools with controls, including controls, and the effect remains. I also present this result by test because it's interesting that in Saber 3 we have a effect of 0.15 deviations, standard deviation, and 0.13. For 5th grade, we have again an effect of 0.5 standard deviation. But for Saber 9, we had a less effect that is 0.10 deviation, standard deviation, and in 11th grade we don't have any effect. So these cultural centers are influencing more those students younger. Here I present the coefficient by for the dynamic version of the model. Here you again can see that we have an effect around 0.1 for math and language, but this effect is bigger in languages. And you can also see that before the treatment, we don't have any effect in the coefficient. So this is a confirmation of the parallel trends assumption. Here I present these results for the other outcomes. You can see that we don't have any effect for approval of subtransfers. This means that this policy doesn't generate that students can transfer to other schools, and we find a negative effect in men for approval and a positive effect for transfer. But when we did the specification, the dynamic version of the model, we don't see any significant results. Also, we present this table disaggregate for women and men because we cannot say anything about what of the surveys of the cultural centers are influencing the students in order to obtain better performance in the test scores. And the first thought, what does Probably women can be more interested in cultural activities, and men who could be more interested in sport activities. But as you can see, we don't find any difference between women and women. Here I present the result for crime. We find that a reduction of motorcycles and resident threats in 0.12 deviation standard deviation, and we don't find any effect for homicide cars and people drive. And here I present the result for motorcycles and resident thefts, and you can see a positive results, a reduction in the crime, only for the second year before the treatment. And you can see also that parallel trends assumption is not so clear in this case. About the robustness check, this is the last part of the results. I use other buffers. As I told you before, I use 1.5 kilometer distance based on the walking time, but this could be generating a bias in my estimator. So I did the econometrical model with buffers between 1 and 2.5 kilometers around its center. And here I present the result for all the specification. So in my assumption is good, I have to see that in the smaller buffers, there is a biggest effect. And we find this, and it's also, this graph is also has a very similar trajectory in all the specification. So this coefficient after the implementation of the cultural centers are positive and significant, and those before the implementation are not significant. I also present here these results without the four municipalities where we don't have any treatment unit at, and the graphs are very similar for both outcomes. Here I present the result for crime for this specification, and again we can see the same pattern in both graphs. And the last robustness check that I present is the intensity treatment. I estimate this equation that is very similar to the principal equation, but now my treatment variable is intensity I, that is the number of centers to which a unit is nearby using 1.5 kilometers buffers. So here is the result for that specification for education. And we find that when a school can be close to until 4 UAS. And we can see here that all the coefficients are positive and significant, but the biggest effect is when a school is closest to 2 UAS. And we find a positive result for 3 and 4 UAS, but this is smaller. Here I present this for crime, and again you can see for resident thefts a negative effect since 3 UAS to 6 UAS, and a negative effect for motorcycle, but this is strain, only for 3, 5, and 6 UAS. And we also obtain a strain effect for homicide and car. And I don't have more time, so I'm going to conclude. This paper provides evidence of the effect of the provision of public goods on education and crime outcomes. A school close to the center obtained an increase of 0.1 standard deviation in the results of language and math. Neighborhoods close to cultural centers obtained a reduction in motorcycles and car threats by 0.11 standard deviation. And in these papers, I present evidence that a policy focused on disadvantaged population that participates in the design of this have the directly implication of the welfare of the community. So this is all. Thank you again for being here, and all your comments and questions are welcome.
Thank you very much, Carolina. Thank you very much, Carolina, for your presentation. Thank you for adjust your presentation to the time. And now I invite Aldo to make the presentation. Please, Aldo.
Thanks, Javier. Thank you very much. I will present a joint paper with Eduardo Hidalgo and Nayeli Salgado. And before I begin, let me just clarify a couple of concepts. Define indigenous institutions as the political complexity of an ethnic group in pre-colonial times. A nation building is defined as the use of state power in order to forge a national identity. So having said this, let me just move on to the motivation of the paper. We know that large-scale infrastructure projects tend to be rejected by indigenous people. In this picture, we can see indigenous people in Mexico protesting against the construction of a road called Carreteras de las Culturas, which is part of this mega development project called El Tren Maya, or the Mayan Train, which is meant to connect various parts in the southern regions in Mexico. While indeed this mega project will bring new jobs into the communities, as well as will have a very positive impact on prosperity in the long term, indigenous people have been rejecting this mega project. And what's interesting is that this is not only present in Mexico. According to the United Nations, indigenous people have been protesting and rejecting against the construction of mega projects. So while this is true, what we don't know is which indigenous groups are more capable of opposing large-scale infrastructure projects. So this is a key research question of the paper. We want to understand which indigenous groups are better able to reject large-scale infrastructure projects, but also we want to understand what are the main mechanisms that could explain this association. And to investigate this issue, we relied on this unique experimental setting from the aftermath of the Mexican Revolution, in which arguably between the period 1920s and 1950s, roads were used as a tool for nation building. In this slide, you can see essentially the main finding of the paper. You observe the evolution of road infrastructure in Mexico within our period of analysis across two sets of municipalities, fragmented municipalities and centralized municipalities. And it's clear that road infrastructure penetrated more within municipalities with fragmented indigenous groups as compared to municipalities with centralized indigenous groups. The main contribution of the papers is as follows. We contribute to this literature analyzing the association between pre-colonial institutions and economic development, which argues that pre-colonial institution is positively correlated with economic development. We contribute to this literature by showing that the effects of pre-colonial institutions and policy outcomes may also have unintended negative consequences for long-run development. Well, this in a way goes is against this main finding of this literature. We believe that it still confirms one of the key mechanisms that explain the association between pre-colonial institutions and economic development, which argues that centralized indigenous groups are more capable of undertaking more effective collective action as compared to fragmented indigenous groups. Secondly, we contribute to this literature on the determinants of public goods, which argues that ethnic diversity is a key determinant for public good provision. And we contribute in this literature by showing that pre-colonial institutions of ethnic groups are an important determinant of the lack of demand for provision of large-scale public infrastructure, and that this lack of demand is more apparent if this conflicts with the ethnic identity of the indigenous population. And lastly, we contribute in this large literature analyzing the effects of large-scale infrastructure projects on development by showing that in regions with centralized indigenous group, large-scale infrastructure projects tend to be less successful. Indeed, this has very important policy implication, as I will show you later on in my presentation. Sorry. So, as I said to you, we relied on this study setting from the aftermath of the Mexican Revolution, in which the first large-scale road program in Mexico emerged. Before the revolution, essentially in Mexico, there were no big highways, and roads only started to appear after 1925. But more importantly, roads during the post-revolutionary period were used as a tool for nation building. For example, according to Waters, roads mean both a change in individuals' identity by broadening the process of Mexicanidad, and as a way for individuals to come into more direct contact with market forces and institutions of the state. So indeed, roads during these periods emerged and were used as a tool for nation building. And secondly, we believe that this is a very interesting study setting because, as in any part of Latin America, in Mexico, before colonization, there were several ethnic groups which, of course, had a large variation in terms of institutional complexity. So this is the two sources of variation that we want to exploit in order to analyze the key research questions of the paper. And as you can see in this slide, roads in Mexico emerged as a large-scale road infrastructure. You can see the evolution, the variation of road infrastructure in Mexico in our main period of analysis from 1930 to 1960. But again, roads during the post-revolutionary period, indigenous people essentially saw them not as a public good that could improve their living standard, but instead as a threat to the continuation of the indigenous practices and also indigenous identity. For example, in the 1940s, in a municipality of the state in Chiapas, Totse people opposed to road building because they believed that roads would be served as a gateway for Latinos to come to the communities and, of course, have a negative effect on the local practices. And as I explained in my motivation, even today, indigenous people reject this kind of mega projects. For example, these Carreteras de las Culturas, indigenous people believe that these kind of mega projects will only benefit businessmen, but not indigenous people. And even the president of Mexico, Andrés Manuel López Obrador, had to intervene to encourage indigenous people to accept this mega project by arguing that they should not be looking at the past of dispossession and repression, and instead they should be looking at to the future, because of course the idea is that this project will bring a lot of prosperity to their communities. Nevertheless, indigenous people have been rejecting these mega projects so far. So in order to investigate this issue, we constructed this unique data set in which we digitize and view reference data on road infrastructure taken from these two sources, the Mexican Ministry of Transportation and the National Archives of Mexico. So after we have digitized this road network in Mexico, we follow this paper from Dalgard and others, 2018, and create buffers of 1 kilometer along each side of the road, as you can see in the image in the slide. And then we simply compute the share of the area of buffers within each municipality between 1920, which is the period where there were no highways or roads in Mexico, to 1960. And of course, this would be our main dependent variable in all our specification. But as a robustness check, we also use buffers of different sizes, and importantly, our results still remain the same. Our key variable of interest was this Indigenous Institution Index, which was taken from Elizalde, which is forthcoming in the JDE, which uses these two pieces of information, anthropological data from Murdoch's ethnographic atlas and indigenous population data digitized from different censuses since the early 20th century. Regarding the anthropological data, we relied on this anthropological variable, which essentially classifies in ethnic groups based on the respective levels of political complexity before colonization, which ranged from 0 to 4, where lower values essentially denote more fragmented ethnic groups, and higher values, of course, represent the opposite. And if you combine these two pieces of information, you end up with this weighted population average of this anthropological variable for all the indigenous groups in Mexico within each municipality. And as you can see in our index, we use all information from the 1930 census because we believe that this will reduce some kind of contamination in our index as a result of movements of indigenous people from one region to another. Nevertheless, we use different forms of this index, such as the continuous value of the index, but we also take the average of the index in our period of the study, which is from 1930 to 1960, and the result still remain the same. And using this continuous value of the index, we created a centralization variable, which essentially classifies municipalities as fragmented and centralized. So we regard a municipality as centralized if this index on indigenous institution is higher than 0, but if the index is equal to 0, we regard a municipality as fragmented. So essentially, this index follows the literature, in particularly the paper from Dippel 2014, and of course, the seminal work from Jenna Yoli and Rainel 2007. So in this slide, you can see the variation of our index on indigenous institution, and it's very clear that the variation comes from the south of Mexico, which traditionally is a part of Mexico where more advanced indigenous groups tend to live. So our main empirical specification exploits the differences in road infrastructure across municipalities with different levels of indigenous institutions before and after the road program began. In this case, I'm showing you a flexible diff approach, which essentially interact our index on indigenous institution with our set of dummies of time. So essentially, we're going to be comparing our estimation with our baseline category, which in this case is 1920, when there were no highways in Mexico. And of course, this empirical specification includes a rich set of fixed effects, for example, state by census fixed effects, which will allow us to control for shocks that affect a specific municipality in a specific time period. And we also include a rich set of geographical and historical factors, as well as time variant covariance, such as the total population, the share of the indigenous population, and as well as different variables on ethnic diversity, such as ethnic fractionalization and ethnic polarization, which will allow us to disregard alternative mechanisms in our empirical specification. In this slide, you can see the main finding of the paper. It is clear, I'm showing you the coefficient from our flexible diff and diff approach and with confident intervals. It is clear that differences in road infrastructure were much lower in municipalities with more complex indigenous institutions. And when we compare fragmented versus centralized municipality, the effect is still the same. We observe that road infrastructure was much lower in centralized municipality as compared to fragmented municipalities. Now, of course, we carry on several exercises in order to check the robustness of our results. In order to validate our empirical strategy in terms of the parallel trend assumption, we correlate our indigenous institution index with different pre-revolutionary transportation infrastructure outcomes, such as colonial roads and railways by 1910, and we find that these variables don't have any association with our Indigenous Institution Index. And in order to further exploit the parallel trend assumption, we exploit post-nation building variation of road infrastructure when arguably roads were no longer used as a tool for nation building, which is a period when it started from the 1960s and onwards. And what we find is that road share essentially follows parallel trend between centralized and fragmented municipality. We also carry on different tests in order to rule out alternative mechanisms. For example, one important point is that perhaps one will argue that this was not a demand side issue, but instead it was some kind of lack of supply issue, which suggests that the state will be discriminating municipalities where they are or they were indigenous people. But what we found is that the expansion of road infrastructure is essentially the same between municipalities with or without indigenous population. And to further address concerns in terms of discriminatory policy against indigenous people, in all our specifications, we control for the share of indigenous people. And in order to tackle issues around ethnic diversity, which is a key determinant for public good provision, in all our specifications, we control for our measures of ethnic fractionalization and ethnic polarization. So I'm very happy to explain these exercises, if you like, at the end of my presentation, but let's just move on to the second part of the paper. In the second part of the paper, we then ask, why is that road infrastructure was much lower in municipalities with centralized indigenous institutions? And for that, we propose two main mechanisms. The first mechanism argues that because of the legacy of pre-colonial centralization institutions, better cultural attitudes for collective actions were developed in municipalities with centralized indigenous institutions, which suggests that centralized indigenous groups tend to have more collective action practices as compared to fragmented indigenous groups. This mechanism essentially is the same as the one that is used in the DALE 2018, which essentially uses a similar mechanism on local collective action. Our second mechanism argues that individuals with centralized indigenous institutions will have a much higher utility for preserving their indigenous identity. Therefore, it will have a much higher interest in rejecting road infrastructure than individuals with fragmented indigenous institutions. In this presentation, I just want to show you evidence for mechanism one on collective action due to time constraint. And for this, what we did was to exploit the ancestral land distribution that appeared after the Mexican Revolution. Then, over a period of about 75 years, the state distributed 16 million hectares of ancestral land to the indigenous population. And what's interesting about this case is that ancestral land distribution was not a straightforward process. Indigenous people had to organize themselves in order to ensure that their land petitions were going to be successful. Therefore, they relied on a wide range of collective methods, such as land invasion, barricades, and even they implemented small guerrillas within their communities. So therefore, what we did was simply to check whether ancestral land distribution follow different trends in municipalities with different levels of indigenous institutions. So we simply use as our dependent variable ancestral land distribution and apply the same flexible diff in diff that you saw in my previous slide. And the results can be seen in this slide. For example, when we compare fragmented against centralized municipalities, we observe that differences in ancestral land distribution were much higher in centralized municipality as compared to fragmented municipality, which of course provides evidence in terms of our mechanisms on collective action, suggesting that
centralized indigenous groups are more capable to undertake more effective collective action as compared to fragmented indigenous groups. Now, this final part of the paper then asks what were the long-term economic consequences of road infrastructure. And for that, we simply correlate our index on indigenous institutions and our variable on road share by 1960. And as you can see in this slide, road share by 1960 is positively correlated with each of the present day outcomes that we have in this table. Of course, these results have very important policy implication because it suggests that in areas where more centralized indigenous groups live, larger scale infrastructure projects tend to be less successful. Now, let me just conclude very quickly. In this paper, what we find? Well, we find something really interesting. We find that large scale infrastructure projects tend to be less successful in regions with centralized indigenous institutions as compared to fragmented indigenous groups. We also, in our specific case of Mexico, we find that these trend differences in road share are only significant during this process of nation building. Possible mechanism, of course, one is better collective actions among centralized indigenous groups, which suggests that centralized indigenous groups are more capable to ensure that the political demands are going to be heard by the state. The other mechanism, which I didn't provide evidence in this presentation, basically argues that centralized groups are more likely to preserve and therefore protect the indigenous identity and tradition as compared to fragmented indigenous groups. And one point which is we believe is very important is that the supply side doesn't really matter. Differences in road infrastructure essentially are the same in municipalities with or without indigenous population. So our take in this paper is very straightforward. We relied on this unique study setting from the aftermath of the Mexican Revolution, when the first large-scale road infrastructure program emerged and was used as a tool for nation building. However, indigenous people didn't see this policy as a positive outcome. Instead, they saw this policy as a threat to their identity and local practices, therefore, they rejected road infrastructure. However, only municipalities with centralized indigenous groups were better able to reject this mega project due to the legacy of more complex political organization. And of course, our results have important policy implications because by understanding which indigenous groups are better able to reject large-scale infrastructure projects, this will enable government to tailor negotiating strategies in which that it will make this project more successful and less of a threat for indigenous communities. So thank you for listening. I'm very happy to answer any question that you may have.
Thank you very much, Aldo, for your presentation.
Right. I think if there are questions that people may ask, you can go ahead and ask, or maybe you want to decide to answer to ask questions at the end of Javier's presentation. So it's up to the participant of the session whether they want to do it just now or whether you want to do it at the end of Javier's presentation. So the floor is open for any question that you may have. Right. Okay. So it seems that there is no question. So now it's time for Javier's presentation, and now I'm just gonna try to chair the session. And so Javier, you have 25 minutes and 5 minutes of question and answer. So you can start with your presentation.
Thank you very much, Aldo. Okay. Do you see my presentation? Okay. Okay, thank you very much. Excuse me, do you see my presentation? Okay, well,
yes, Javier, we can see
much.
your presentation. Perhaps you want to zoom out your presentation so we can have it in a presentation mode rather than just, yeah, that's perfect. Thank you very much.
Okay, well, this presentation was sponsored by the Andean Development Bank, and I made this paper in collaboration with Alejandra Terán. Alejandra and myself are both part of INESAT, which is the Institute of Advanced Studies in Economics. And we made this paper in collaboration also with the University of Cartagena in Colombia and the Bolivian Academy of Economic Science. The name of the paper is Vehicle Fleet Path, a nonlinear relation of ownership elasticity, and it's a forecasting a forecasting model between 2000 and 2013. I'm going to explain the motivation. Okay. I have a very clear research question, which was the impact of the economic boom of the vehicle fleet in Bolivia during the period 2006-2015. And this is a very relevant question because we have a vast literature showing that there is a clear non-linear relationship between economic boom and the increase of vehicle fleets. Vehicle fleet is the accumulation of vehicle stock in a period of time. And there is a vast literature showing that when a country experiences an economic boom, there is also a huge increase in the vehicle fleets. And this increase has several implications in the demand of derivatives, oil derivatives, and CO2 emissions. So my research question is to test this research question in Bolivia during the period 2006-2015 and make a theoretical model. Why a theoretical model? Because this is an empirical evidence, but we need to strengthen this empirical evidence and make a formal model. So I tried to prove the validity of this theoretical model using first order logic model, and then use this first order logic model to develop a common macroeconomic model, which I will include in the paper. So I'm not going to take much time in the literature because I also explained the main characteristics of our model, but the idea is that we will examine some key factors like buttoning oil, yeah, like income, price of fuels, urbanization degree, and other drivers. We follow some assumption that made Darbyke, not only in 1997, but more recent papers for 1918, which include this nonlinear relationship between the increase of income and the increase of vehicle fleets. Yeah, and then we will forecast. To forecast, we will follow some recommendation made by Medlock and Soligo, and some recommendation made by Ceylan, Bascan, and Osan, 2018. And we built an accounting model. This accounting model was made in GAMS. We programmed a model in GAMS, which is a typical bottom-up general equilibrium model, which is different from the common general equilibrium top-down models. Yeah, the difference is that the typical top-down general equilibrium models are more based on production function, and the bottom-up general equilibrium model try to reproduce the energy mix of a country in order to introduce some inertial behaviors of key drivers like population growth, another driver that push the consumption of energy, but with a strong link with a technology. Our model introduced technology, a specific technology, not a generic technology. This is something really interesting. So we follow the literature, but it's interesting that all of this literature is only empiric. They have empiric results. So we will try to formalize with this logic model and to prove the precondition to establish a more macroeconomic theoretical model. Okay, part of our background, very simple, is that we show how population evolved between 1970 to 2017. And then we also evaluate the population density, urbanization, and the evolution of car fleets. And in the graph, you will see how the car stock evolved over the time, how population evolved over the time, and it's something interesting and really important, the precise point when the car stock curve start to behave like an exponential curve. Yeah, this is part of our background. Our model since is something really important to define a non-linear relationship between the evolution of income and the evolution of car fleet over the time. We will use a Gompers-Richardson curve model, which is equation number 1. As you can see, C is the long-term equilibrium for vehicle ownership per 1,000 people. GDP is the per capita GDP expressed in real dollars, PPP. And delta is the saturation level. Saturation level is quite complex to calculate because it's a value, it's a parameter that reflects urbanization, population growth, and some conditions like space in a country, because if you increase the number of cars in a city, you will need a space to increase this number of cars. You can't increase the number of cars without any constraint. So this saturation reflects these constraints, and it's quite complex to estimate. So we estimate in another model, and then we include in the equation. Beta and alpha captures the shape and the saturation point of the curve. Notice that these two parameters are negative, and you can see in the graph in the bottom right, this is some possible trajectory to Gompers-Richardson curve, and we will try to calculate alpha and beta. Yeah, so at the end, we estimate this equation like the logarithm of this delta divided by the long-term equilibrium of cars minus alpha parameter, the logarithm of minus alpha, plus this saturation, yeah, and times the GDP per capita. Yeah, so this equation we will estimate econometrically in order to understand the shape of this curve that is in the graph in the right side. Okay, so something that is interesting, since the equation is of the curve is non-linear, the elasticity is not constant over the time. As you can see in the figure 3, you have in the first graph the shape of the Gompers-Richardson equation, yeah, and which is clear non-linear. And in the other side is the elasticity, which is not constant over the time. And we will also estimate this elasticity, not directly by our econometric estimation. We will make Monte Carlo simulation to estimate this income ownership elasticity, which is important because at the top of this elasticity is the saturation. And the saturation has serious and several implications in public policy, in transport public policy. And it implies millions of dollars to this value will help to define really, really important public policy. So it's very, very important to calculate in a good manner. Yeah. And the other interesting thing is that we will determine the exactly point where the Gompers-Richardson curve will start to tip, to change the trend of the curve. Um, these two points are critical for public policy, especially for energy transport public policy. In order to calculate this saturation level, we will use two parameters, lambda and the other parameter I don't remember, and we will define D as the population density for each of the departments. In the case of Bolivia, we have 9 departments, so we will use the average of the country related to the average of each specific department. If the density of a country is higher than the average is 1, and in other case, otherwise is 0. The same is for urban. And then we will estimate the saturation level based on these two equations, equation 5 and 6. Since we estimate, or excuse me, when we estimate this C, this car stock in the long term, then we will introduce this value to this accounting model. As you can see, equation 8 means the energy consumption for equivalent fleet. Yeah, it's the evolution of cars times energy intensity. Energy intensity is the energy that a car consumes for a unit of time or a unit of production. Yeah, so we estimate this Gompers-Richardson equation just to include this C in the equation number 8. Yeah, and notice that T is the time, B is the technology, and S is the scenario under analysis. This is our bottom-up general equilibrium model. Energy intensity is quite complex to estimate. Usually is the number of cars times annual vehicle measure times fuel economy, which is quite difficult to estimate. To proxy this energy intensity, we use this composition. It's not part of this paper because it's a paper that I already made in 2014, but this modified this composition of energy consumption led us to understand how the energy intensity of this equation, this Gompers-Richardson equation, interact with our general equilibrium accounting model. And since we define, or when we define the evolution of cars and the consumption of energy in terms of fuel or whatever, we will able to estimate emission. Emission is the quantity of cars times the emission factor times degradation. Degradation is the obsolescence or reduction of efficiency of this fleet car. Something interesting is that to make a good exercise, we need to balance the stock of cars. To balance the stock of cars are two possible alternatives. One is, for example, make some equivalence. One car is equal to, or excuse me, 2 motorcycles is equal to 1 car, something like that. And the other possible potential adjustment is between the using the number of passengers of cars and relate these passengers of cars to the evolution of population. This is something that we need to balance the vehicle fleet, and it's very interesting. If you see in table 4, and in the upside of the panel, you will see number of vehicles without, excuse me, with equivalence factor, and in the other panel, in the bottom of the table, vehicles without equivalence factor. And you can see that there is a difference between, for example, in total for the year 2003, in total, in one of the exposure is 7,000 to 22,000 cars, and the other is 4,043. This is the equivalence of cars because we are relating the consumption to the numbers. So it's very important to make a good calculation, and it's very difficult to do. Since our model is non-linear, we detect a lot of outliers, and we don't want to eliminate those outliers, then we choose some to make a robust nonlinear econometric model. So we ran this technique. We test three specifications: the M estimation, the S estimation, and a combined and hybrid estimation and MEM estimation. And with robust econometric, we decide to run this model, to estimate this model with the S estimation. See, we found this huge leverage effect in our estimation. As you can see in our result, we estimate variable A and B, which are the parameter of Richardson-Gomper's equation. They are both are significant, and based on this estimation, we detect that the saturation point of our vehicle fleet is 741 cars per 1,000 people. Okay, and here is our equation. This is the adjustment of our Gomper-Richardson equation. And on the other side, you can see the elasticity we estimate for income holding vehicles. Both are very consistent with the literature. And then we introduce this in our accounting model, and you can see the paths of different production. The first table is consumption, production, and imports. So you can see the consumption of the different oil derivatives between 2000 to 2013. Then you can see the production, and as you can see, we need to import some resources, and these resources implies a total emission in gigagrams of CO2 equivalent. And this emission, as you can see in the graph, is without any energy efficiency measure. If we introduce in our accounting model and new scenarios with energy efficiency measures, you can see the red line. This is the savings in terms of fuels. Our conclusions. First, we prove the biconditional relationship because vehicle ownership and per capita income, as we expect, is highly nonlinear. This is something very, very important to prove. Then the income elasticity began at a very low level, which is consistent with literature, since Bolivia is a poor country, yeah, but increased really rapid. It means that when someone in Bolivia has $2,500, they decide to buy a car, which is, it's really a low level to take this decision. During the period 2006 to 2015, we verified that the vehicle fleet increases or over increases because since we experience an economic boom, we have an average increase of cars during previous period, and we verified that this overshoot. So we increased 12.8 times cars greater than 2016. It means that we increase the number of cars in a huge manner that will also push derivatives of the production and consumption of derivatives. Yeah, and this is very problematic because we expect 7.93 times more emission by 2013 than the base scenario. If we introduce this energy efficient measure that we use in the second scenario, in the mitigation scenario compared to the baseline, we will have an estimated saving of $5,400 million during the next 10 years. To prove our model, we ran this first logic model to prove that we have 7 theoretical models feasible to develop this macroeconomic, more formal model. And in this paper, concretely, we verify the first model. Thank you very much.
Thank you very much, Javier. Now, we open the floor for question and answers for Javier's presentation. So please feel free to write your questions on the question and answer chat that is available on Zoom.
So I'll give you time to see if some participant would like to ask a question to Javier, or either Javier, Carolina, or myself. Please do feel free to do so. Right, I guess that there are no questions. Maybe we were very clear with our presentation, so I'm very happy with that. If there are no questions, I don't know if maybe we just gonna regard this as a conclusion. We just want to thank you for participating in our session, and if perhaps, don't know if Javier or Carolina would like to add something at this point.
No, from my side, thank you very much for the opportunity to present this paper in progress. And thank you very much for my co-chair Aldo and for the good co-chairing.
But thank you very much. Thank you very much, Carolina. Thank you, Javier. So thank you very much for all the participants. Sergio, would you like to close the session and then just go on to private mood so we can talk, maybe Javier and Carolina among us? Well, I think Sergio is not there. Okay.
Actually, I think that the host has to end the webinar.
Excellent. Okay, so that's all for us. Thank you very much. Thank you, Javier. A pleasure to share.
Thank you, Aldo and Javier.
Thank you, Carolina.
A pleasure.
See you around.
Bye-bye.
Bye-bye to everyone.